Welcome to section 11.1, Intro to Limits. So now we are officially beginning calculus. This will be one of the first things that you guys do when you get to Calc 1 in college, or if you decide to take Calc A, B, or BC here, and it is evaluating limits. So, quick reminder, when we go through and do limits, it's not about actually getting to the x value. So in this case, the limit as x approaches 3. It's not about landing on 3, it's about getting really close to 3, and then finding out what the y value is doing, or what y value you're getting closer to. So I figured in section 11.1, we'll actually take a look at things graphically more than anything else. And then we will also, in the next section, and maybe later in this section, we'll talk about, well, if I just plug the number in, what happens? So that's called direct substitution. So I think the first thing that I want to do is take my function, 2x minus 1, and graph it. So let's take a look at that graph. Now that we have the graph on the paper, just a regular line back from Algebra 1, we want to focus in on that x value that we're trying to approach. So I'm going to use an orange highlighter on this one. I want to highlight that x value I'm trying to approach, and I'll go back over here to my graph and I'll find that x value on my graph. I'm just going to highlight that area that I'm looking for. So remember, it's all about the approach. So I'm going to approach from the left and I'm going to approach from the right. So I'm going to focus in on that orange line, and as I come in from the left-hand side, I want to see what is happening to my y value. So as I come in from the left, I want to get closer and closer and closer to that x equals 3 part. And what I'm doing is I'm trying to focus on where that y value is. So to me, it looks like, I actually shot past it. It looks to me like I'm going to hone in right here as I come in. So it looks like my x value is going to be my y value is 1, 2, 3, 4. Actually looks like I'm pretty close to 5. So what I would say then is that my limit as x approaches 3 from the left, so that little negative notation means from the left, and it looks like the y value is going to be 5. So I'm getting closer and closer and closer to 5. So now I'm going to do the same thing. I'm going to come in from the right-hand side, and I think I'm just going to choose a different color. So let's do blue from the right-hand side. Do the same thing. So as I come in from the right, up here, I want to approach and get closer and closer and closer to that same orange line. Well, lo and behold, it looks like I am going to get to that same y value. So my limit as x approaches 3 from the right of f of x, still keeping my blue, is going to be the same. It's going to be 5. If those two values are the same, so from the left you get to the same, or you're approaching the same y value that you approach from the right, then we can say that the overall limit exists. So because of this statement right here, I can say then that the limit as x approaches 3 of the entire function f of x. So notice that my notation now goes back to what I started with, my overall limit. I can say that that is now 5 because they're both values from the left and from the right. Let's take a look at the next one. So here we are on the next screen, and I already went ahead and did a little bit of work for you on this one. I see that the absolute value of x divided by x is probably not something that you're familiar with. So I went ahead and just made a table like we normally would. So you'll see that I did some work off to the side. I just want to remind you that absolute value just means distance from 0, and taking the absolute value of a negative number is always going to be positive. So you'll notice that I picked some numbers that are whole and some numbers that are decimals. Just as a reminder, if I picked any decimal in here that is negative, so negative 0.3719, if I took the absolute value of that, I would get positive 0.3719, but then it'd still be divided by a negative 0.3719. So every negative number I plug into this is going to give me a negative 1 value. Every positive number is going to give me a positive 1 value. So I would go ahead and graph this. Now I have that undefined happening at 0, so we'd have to determine whether or not that's going to be a whole, or looks like a jump in the graph, or an asymptote. Now, based off of the behavior, I would say that this is definitely not an asymptote, because behavior of asymptotes is that the graph tries to race to it and hug it. So I don't have this hugging happening because I'm at -1 and 1 consistently, so I'd say it's just going to look like a jump. So let's go ahead and graph this and see what it looks like. So now I have a sketch of my graph. You'll notice that I put holes at those 0 locations, and then I have this clear jump. So anything that was negative gave me -1, anything that's positive is going to give me +1. So let's go ahead and see if we can now evaluate the limit. So I'm going to go back up. I'm going to highlight the limit I'm looking at. I'm trying to approach 0. So I'm going to highlight where x is equal to 0. And I'm going to come in from the left and come in from the right. So coming in from the left, it looks like I'm staying consistently at this -1 value. So remember, it's all about the approach. So the y value that I am approaching is -1. You'll notice because there's a hole in the graph, I don't actually get there. But that's okay, because limits are all about the approach. So what I can say on this left-hand side then is that the limit as x approaches 0 from the left of my function is going to be -1. Remember, it is the y value that you are approaching as you get closer to the x value in question. So I'm going to do the same thing from the right. So I'm going to try to approach that orange line, and I'm coming from the right on the graph, and it looks like it's approaching a y value of 1. It's not going to actually hit it, but it gets really darn close to it. So I would say then from the right, my limit as x approaches 0 from the right of my function is actually going to be 1. Now, in order for a limit to exist, those two values that they approach have to be the exact same number. However, at this point in your math career, we all know that +1 and -1 are not the same numbers. So what I can say, therefore, is that the limit as x approaches 0 overall, so from the right and from the left, of f of x is not going to exist because it's approaching two completely different values. It has to be the same value if the limit is going to exist. Let's take a look at the next one. So taking a look at our next function, we have a piecewise defined function, so it should look familiar from first semester. I have that f of x is going to be equal to 2, so y equals 2, so it looks like a flat line, except at x equals 3. When it gets to x equals 3, it's not going to be at 2 anymore. So I have this straight line that's going to have a hole in it where the x is 3. When x is equal to 3, it's going to be at 0. So take a look, I've got my graph off to the side. I'm going to do the exact same thing that I did previously. I am going to focus in on the limit or the x value I'm trying to approach. So I'll go to where x equals 3 and I will mark that as my location that I am approaching, and now I'm going to come in from the left and the right. So as I come in from the left, remember it's all about the x value, it's all about the y value that you are getting close to as you get closer and closer and closer to the x value of 3. So in this case it looks like, as I come in from the left, that I stay consistently at a y value of 2. Now, remember, it's not about getting there, it's about the approach. So I am approaching 2 from the left. I do the same thing from the right. So I come in from the right, trying to get closer and closer and closer to that orange line, and the y value that I am approaching, well, it looks like it's also 2. So my limit as x approaches 3 from the right for my original function is also 2. Now you'll notice that there's a jump in the graph, which might be causing you a little bit of heartache here. It doesn't matter where the point is on the graph when x is 3. It matters what y value you are getting close to. I am getting close to the number 2. I'm not even getting close to that 0. It's way down below the line. It's not even close to my approach. So, because I do have the same values here, I can say that my overall limit as x approaches 3 of f of x is going to be 2, because it's the exact same value. Okay, so on to our final example for section 11.1. We want to find the limit as x approaches 0 of f of x, where the function is defined as 1 over x squared. So, since I wasn't positive what this was going to look like, I went ahead and make a table. Filled in the table, you notice that it's going to be undefined at 0. But if I take a look at this one now with the behavior of the graph, I'm confident that this is going to be an asymptote, simply because what the behavior is with the x and the f of x as I get closer to 0. It's hugging, and the values are both increasing, actually. So we'll do the exact same thing that I did before. I'm going to approach from the left, and I'm going to approach from the right, and I'm trying to focus in on that x equals 0. So let's go back over here. I'm going to highlight the line that I'm trying to see what's happening here, and I'm going to come in from the left. So coming in from the left, I want to get closer and closer and closer to that orange line, and I'm trying to figure out what y value I am approaching. Well, I think we have a problem here. This graph is going to continue going on forever because of the behavior of the asymptote, and the asymptote being where I'm trying to approach. I know that this is just going to blow up. I'm going to keep getting larger and larger and larger. So I would say that the limit as x approaches 0 from the left of f of x. Now this can be identified a couple of different ways, and really it does depend on the textbook that you use. So, some textbooks would say that the limit that you are approaching does not exist because we expect a limit to be an actual number. In this case, that number that it would be approaching isn't really a number, it's infinity. So, for now, I would say the limit does not exist because the value I'm approaching is infinity. And infinity isn't an actual number. It's an idea that there are more numbers out there. So let's do the same from the right. So from the right, hopefully you'll see that the behavior is going to be the exact same thing. It's going to keep blowing up. So I'm not going to actually get closer to any any y value. So my limit as x approaches 0 from the right of f of x also does not exist. The reason? Because I am approaching infinity. Now, you might say to yourself, but infinity and infinity are the same, so I'm approaching the same value. Well, not really. You're trying to approach a finite location, an actual value. Infinity isn't a value, it's just an idea. So, because I am approaching infinity, that means that my limit will not exist. So the limit as x approaches 0 overall of my function does not exist. And you'll notice in your notes that we have the rules written down for when a limit does and does not exist. Make sure that you have those rules memorized, so these are a little bit easier to do. If you have any questions, make sure you ask in class.